In this lecture, I'm going to show that the limit of a function does not exist. And I'm going to pick a function in two variables, x comma y. So there's a z here. So this is the function, and the function does not exist at 0, 0. Right? Because you can't have division by 0. However, it doesn't mean that the limit does not exist. So we're going to take the limit of the function, this particular function, as the points x comma y get closer and closer to 0, 0. Now, it turns out that this limit does not exist. So to prove that, all we need to show are, if this is the xy plane, and so the function comes out of the board, at 0, 0 the function doesn't exist, so it has a hole in it. But it doesn't mean that the limit doesn't exist. And again, in our example, it's going to be true that it doesn't exist, but how do we prove that? What you have to do is look at paths getting closer and closer to the point 0, 0. Say that path and that path and that path and that path, and you got to look at them all. And how many of them are there? Infinite. In fact, here's another path, and here's another path. So to prove that the limit exists, you have to look at all of them, infinite number. And to prove that it does not exist, all you have to do is find two paths where the limit is different. And that's the case here. So I'm already giving you the answer, but we're not going to have to prove it. So let's take the path when x is equal to 0. So x is 0. So now we're talking about this path and this path. So what do we have when x is 0? Well, we have 0 in the numerator, and we have 0 squared is 0, plus y squared. Now, y is not equal to 0. Okay? Y approaches 0. It's not equal to 0. So this is just a number. So this is 0 divided by a number. What? That's 0. So the limit taking the path associated with x equals 0 is 0. Now similarly, if we take the path where y is 0, we're talking about this guy and this guy. So what do you have? Y is 0. Well, that's 0 over x squared plus 0 squared is 0. And again, this is a number. X can never be equal to 0. We care about when x approaches 0. So 0 divided by a number, again, well, that's 0. So it's looking like this function has a limit of 0. But we have to check all paths. So how many paths are there? Well, we did 2. How many more do we have to do? Infinity minus 2. Okay, so hopefully the third try will be the trick. What does it y equals x mean? Well, that's a line that looks like this. So now we're looking at this path and this path. So what do we get? If x and y are the same thing, then we have x times y, which is the same as x times x, or x squared. In the denominator, we have x squared plus, well, y squared is the same as x squared. So this is x squared over 2x squared. Again, x is not 0, it approaches 0, so this is a number. This is the same number, so they necessarily cancel. So we're left with 1/2. So this limit along this path is different from this limit along this path. So when the limits are different with respect to different paths, we say that the function the limit of the function as xy goes to 0, 0 does not exist. Okay? So that's my example, and that's the end of this lecture. Thank you.